Hello everyone, this is Pravesh Malviya. Now we are going to discuss about open circuit and short circuit test on a transformer. So the first question arises in mind that why do we perform these tests? So for a particular transformer, if we have to find out its efficiency, voltage regulation and circuit parameters, so these parameters can be determined with the help of these open circuit and short circuit test. Now one good thing about these tests is that these tests can be performed without actual loading, so we can save a huge amount of power. Now going to the open circuit test first. So the purpose of open circuit test is to determine no load current and losses. Now we can see the circuit diagram of this open circuit test for a transformer. We can see that we have kept open the high voltage winding of the transformer. We can say that the secondary winding of a transformer is kept open, so we can connect a voltage here, voltmeter, to calculate the induced EMF in secondary winding. And looking at the primary circuit, in the primary winding we are feeding a voltage, alternating voltage V, and this voltage can be measured with the help of this voltmeter. The wattmeter will give the reading of power consumed during this no load operation, and this ammeter will give the reading of no load current. Remember, this no load current has two components, the working component IW and the magnetizing component IM. Now with the help of this auto transformer we can adjust the input voltage for the primary winding. Now we can see here that there is no flow of current in the secondary winding because it is kept open. So talking about some losses, there will be no copper loss in the secondary winding as there is no flow of current. So the copper loss in no load operation exists only in the primary winding. And talking about the iron losses, which are also known as the core losses, so the iron losses are fixed for all type of loads. These are the constant losses which will not vary. So coming to the calculation part, let W0 is the wattmeter reading, V1 is the voltmeter reading, and I0 is the ammeter reading. I0 is the no load current, V1 is the input voltage to the primary winding, and W0 is the power consumed in the primary winding. So the iron loss of the transformer can be given as W0 is equal to V1 I0 cos phi naught, where V1 is the primary voltage, I0 is the no load current, and cos phi naught is the no load power factor. So this is the equation number 1, and we can write cos phi naught as W0 upon V1 I0. Now we know that the working component is IW, and IW is W0 upon V1. So putting the value of W0 from the equation 1, we can write it mathematically as IW is equal to I0 cos phi naught, and the magnetizing component is IM is equal to under root I0 square minus IW square. So these are the two components, IM, the magnetizing component, and the working component, and these are the components of the no load current. Now the no load parameters can be given as equivalent exciting resistance R0 can be given as V1 upon IW, and the exciting reactance can be given as X0 is equal to V1 upon IM. Now the phasor diagram, here is the phasor diagram where this is the flux phi and it is in phase with the magnetizing component of the no load current, and there is 90-degree angle between the magnetizing component and the working component of the no load current, and here I naught is the no load current, and there is a angle, no load power factors angle is here phi naught. It is plotted between the input voltage and the no load current, and on the other side we can see the induced EMF of both the windings. E1 is the induced EMF in the primary winding and E2 is the induced EMF of the secondary winding. So this is the entire phasor diagram during the no load condition of a transformer. So the iron losses measured by the open circuit test is used for calculating efficiency of the transformer. So this is all about the open circuit test. Here we can measure the efficiency of the transformer with the help of circuit parameter determined by the open circuit test. So in open circuit test we determined one of the losses, that is the iron loss. Now coming to the short circuit test. So with the help of short circuit test we can determine the copper loss and the equivalent resistance, impedance and leakage reactance. Now this short circuit test is actually performed on the high voltage side of the transformer. This is because of the safety purpose. So here we can see that the low voltage winding is being short circuited with the help of a thick strip, and the high voltage winding is connected to a alternating supply. So this voltmeter, we will measure the voltage of the high voltage winding. A meter will measure the short circuit current of the high voltage winding, and wattmeter will measure the power. And once again with the help of this auto transformer we can vary the input voltage of the transformer. Now there is a common question that why we are performing this test on high voltage winding. So this is because of safety purpose. What's happening? We are feeding the high voltage winding the rated voltage around 5 to 10% of the rated voltage, and there will be lesser amount of induced EMF in the low voltage winding because we are short circuiting it. So we cannot short circuit it on higher level of voltage for the safety purpose. So the low voltage source is applied across the secondary winding, which is approximately 5 to 10% of the normal rated voltage. Now, the flux setup in the core of the transformer, the magnitude of the flux is very small as compared to the normal flux. So, as we are applying 5 to 10% of the rated voltage, a very small amount of voltage we are applying, so the flux is setting up in the core will also be very small. So one of loss, that is iron loss, that depends on the amount of the flux. So in case of short circuit condition, the iron loss will be very less as compared to in open circuit case. Iron loss of the transformer depends on the flux. Iron loss of transformer, it depends on the amount of flux which is set up in the core. It is less occur in the short circuit because of a low value of the flux. Reading of the wattmeter only determines the copper loss occurs in the winding. Voltmeter measures the voltage applied to the high voltage winding. The secondary current induces in the transformer because of the applied voltage. So when we apply input voltage to this high voltage winding, because of mutual induction in low voltage winding there is EMF induced in the winding, and as it is short circuited, a current will flow. That will be the short circuit current. Now coming to the calculation part of this short circuit test. So in calculation part we can see that WC is the reading of the wattmeter which is connected in the high voltage winding. V2SC is the reading of the voltmeter connected in the high voltage winding, and I2SC is the reading of the ammeter. So then full load copper loss of the transformer mathematically can be given as PC is equal to whole square I2FL upon I2SC square WC, where this I2FL is the full load current, and we know that WC, the reading of the wattmeter, is equal to I2SC into RES, where RES is the equivalent resistance referred to the secondary side. So we can write RES is equal to WC upon I2SC square. Now this is the phasor diagram of the short circuited transformer. Now with the help of this phasor diagram, we already studied this phasor diagram. So with the help of this phasor diagram, we can write V2SC is equal to I2SC ZES, where ZES is the equivalent impedance referred to the secondary side of the transformer, and it can be given as ZES is equal to V2SC upon I2SC. Now, the equivalent reactance referred to the secondary side can be given as XES under root whole square ZES square minus RES square. So, here we have found various circuit parameters, and in the short circuit test, the wattmeter record total losses including core loss, but the value of core loss very small as compared to the copper loss. So the core loss can be neglected. Now what's happening in this test, in this short circuit test, as the value of flux which is set up in the core is very small, so the iron losses are very small in magnitude as compared to in case of open circuited test. So here we are determining, in this short circuit test we are determining the copper losses, and in open circuit test we are determining iron losses. So all these losses when determined, we can calculate the efficiency of the transformer. So this is all about these two tests, open circuit and short circuit test. For any query, you can contact me anytime. Thanks for watching.